All right, so I kind of set you up at the end of last video to explain what we're doing. But up until this point, we're able to get our bases to be equivalent. We can cancel them out and just set the exponents equal to each other. When we go to D, we can't do that because when I have 2 to the x power, I can't rewrite 10 as a base of 2, right? 2 squared is 4, 3 squared is 9, 4 squared 16. So we go over and around that 10. So now when my first choice of getting these bases to equal doesn't work, now we need to follow these 2 steps. Just like before with logs, we need to isolate the exponential term. After you isolate the exponential term, then you're going to take the appropriate log on both sides. So we've already dealt with this inverse property, right? We would have log base b of x, and so the opposite of log base b is to raise both sides as an exponent with a base of b. Now we are doing this one here, and I wish I had a different highlighter. But now we are using this inverse function. Okay, so when I have b to the x power, whatever that base is, I am now going to take both sides and add a log base b. So now, just like b to the log of b power cancels, log base b of b cancels, because that's right here, that's 1. And then you are left with whatever that exponent is. Okay, so now I'm using the other inverse property. Okay, and the key of this one is that we have to take that log to both sides. So let's go back to the instructions. It says solve each exponential equation. I need to express solutions in exact form. We are struggling with this terminology of exact form. Exact form means no decimals. No decimals. Okay, so with D, my exponential, that 2 to the x power, that is isolated. So what is the opposite of having an exponent with a base of 2? It's to take both sides as a log base 2. So log base 2 of 2, that cancels, that's 1. And so I'm just left with x. And then on this side here, we now have log base 2 of 10. This is my exact answer right here. You can get a decimal equivalent one of 2 ways. You can first use the change of base formula, which says that this is log base 10 divided by log base 2. So this is about 3.32. Or you can go math up here to log base and say log base 2 of 10. Either way, you get the same answer. If it wants it in exact form, this is the exact form. That is a number, right? When you punch that into your calculator, you get a number. This is your exact form. This is your decimal equivalent. This is your rounded answer. You need to know the difference. All of ours are going to be in this form here. Okay. Okay, so continuing on here, we have 3 to the x power equals 14. I can't get 14 to have a base of 3. So I need to get rid of this exponential. So the opposite of having an exponential with a base of 3, this is taking both sides of a log base 3. So I'm going to do that to both sides here. So log base 3 of 3, that cancels because that's 1. I am just left with whatever the exponent is, in this case, x. And then this side here is log base 3 of 14. That is my exact answer, and you can punch that into the calculator to get the decimal equivalent. Okay, do the same thing here. I can't get this 1.2 to have a base of 8, or vice versa. I can't get this 8 to have a base of 1.2. So because this side over here has my exponent, I want to match its base with the same log base. So we're going to go log base 8 of 8. Those cancel. I am left with negative x. We will do the same thing on this side. So we have log base 8 of 1.2. Now we have not solved for x in this one. We have solved for negative x. So we'll divide both sides by -1 and we get x equals negative log base 8 of 1.2. It is okay to have a negative in front of a log. You just can't have the base, the 8, be negative, or what it's of, that 1.2, to be negative. But the negative out front is perfectly okay. All right, so with these 3 examples, we only had one exponential. When we go on to the next page on G, we now have 2 exponentials. So here we have 3 to the 1 minus 2x power equals 4 to the x power. So with this, you can take either of these to any log you want. Right? Let me pull out my property. Okay, anything that we want here. When I have one side equals the other, you can do log base b and log base b. So you could do common logs, you could do natural logs, you could do log base 4s, you could do log base 3s. It doesn't matter which base you pick. Okay. When you have multiple of these, multiple exponentials, you can do it one of 2 ways. Really one of 3 ways. You could do log base 3s to get rid of this 3, or you could do log base 4 to get rid of this one. Or we could take something kind of neutral, and I'm going to go with a natural log. I'm going to go natural log of 3 to the 1 minus 2x equals the natural log of 4 to the x power. Okay, we can also do common logs. It does not matter which one you want to do. So now I'm going to use this property here, and whatever is my exponent, I can move it in front and it becomes my factor. So I'm going to move this out front, and this becomes 1 minus 2x times log base, or natural log 3, equals, move this x out front, we have x natural log 4. Okay, the goal is to get x by itself, and so before I can do that, I need to distribute basically this natural log of 3. So 1 times natural log of 3 is natural log 3. Negative 2x times natural log 3 is negative 2x natural log 3. Okay. So now I have x's on different sides of the equation. We need to get x on the same side. So what's the opposite of a minus 2? It's to add it. So we're going to add 2x natural log 3 to both sides. Okay, the only thing I have left over here is natural log of 3. And then here I can't combine because you got natural log 4 and natural log 3. So this just becomes x natural log 4 plus 2x natural log 3. Okay, now I'm going to factor out my x. They both have a factor of x. So I'm going to take the GCF of x from both sides. So natural log of 3 equals x natural log 4 plus 2 times natural log 3. And then my last step to get x by itself, this is just x times this, right? You can distribute it back in and get back up to that original, is to divide this over. So that cancels. And so now we have x equals this right here. Natural log of 3, which is just a number, over natural log 4, again a number, plus 2 times the natural log of 3, still a number. Okay, this is how my math lab is going to walk you through how to solve these equations. So when you have an exponential on both sides, it's going to take the natural log of both sides. It would be the same thing if you took the common log. So if you had log 3 over log 4 plus 2 log 3, that'd be the exact same answer. Okay. This is how my math lab shows you. Let me show you a different way on H. You can kind of pick between the two. You don't have to master both, even though both are pretty darn similar. You don't have to master both, but just pick one of the methods you like more. How I would go about solving this is I would pick a log that cancels out one of these exponentials. And I'm going to pick to cancel out the exponential that has a more complicated exponent portion. Okay. So to get rid of this exponential, I need to multiply both sides by a log base 5. And so I will do that to both sides. So log base 5 of 5 cancels each other out, and you are left with just what's in the exponent, which is 1 minus 3x. Okay, this equals log base 5 of 2 to the x power. So now I'm going to move that x out into the front, get it out of the exponent position. And now I can solve for x. 5 log base 5 of 2, like this is a number, right? Just like the natural log of 3 is a number if you punch it into your calculator. So this kind of let me see what I want to do here. This right here is going to travel together. That's stuck together. That is a number. That'd be the same if that was like 10x, okay? So let's get x to the same side of the equation. So I'm going to add this 3x over. These are technically like terms, but because one's in log form and one isn't, I'm going to set them side by side. So this is x log base 5 of 2 plus 3x. No matter what, we're going to take that GCF out of both sides. So I'm going to take x out of both. And this becomes x times log base 5 of 2 plus 3. So now to get x by itself, we'll divide over log base 5 of 2 plus 3 to both sides. So therefore, x is going to equal 1 over log base 5 of 2 plus 3. I prefer this way. and so that's how I'm going to solve I. And that's a lie. No, I'm not. I prefer this way over this way, unless it is in this form here. When you only have one side that's complicated, so in this case, you had a 1 minus 3x, in this case, you had a 1 minus 2x. When you only have one side that's complicated, the other side is just to the x power, I like canceling out one of my exponents. The only time I like this natural log portion or method is when you have both of these exponents here to a complicated exponent, meaning it's not just to the x power. So on I am actually going to use this method here. So that method, I'm going to take both sides here to the natural log. Okay, and this again would work as the common log as well. Okay, that doesn't matter. Just take both sides, either natural log or common log. But this would be natural log of 2 to the x plus 1 power equals the natural log of 5 to the 1 minus 2x power. And now I need to move these over here in front and become a factor. So this is x plus 1 natural log 2 and 1 minus 2x natural log 5. Okay, so I'm going to distribute the natural log of 2 to both of these. So this is x natural log 2 plus 1 times natural log is just natural log 2. And then I'm going to distribute the natural log of 5 to both of these. So natural log of 5 times 1 is natural log 5, and natural log times a negative 2x is a negative 2x natural log 5. Okay, the same thing happens as it did up here, as it does with any equation. I need to get these x terms to one side, and I need to get my constant to the other side as well. Excuse me. It does not matter which way you go. I'm going to get my x over here and my constant over here. So that means I am moving my natural log of 2 over here. So the opposite of a positive natural log of 2 is to subtract it. So that cancels there. And I'm going to move this over here. So plus 2x natural log 5 plus 2x natural log 5. That cancels. So now my equation, these both have a natural log of 2 and a natural log of 5, so those are not the same. So I'm going to put them side by side. So we got x natural log 2 plus 2x natural log 5 equals, same thing here. This is just natural log 5 minus natural log of 2. Now that I have my x's on the same side, I can factor out that x. So this is x natural log 2 plus 2 times the natural log of 5. And then my last step is to divide that over. Okay, so that cancels. And I can't do anything with this because these are all numbers. I can't cancel out a natural log of 2 with a natural log of 2, and I can't cancel out a natural log of 5 and a natural log of 5 because they're not being multiplied, they're being added and subtracted. So this is my final exact answer right here. And of course, you can put that in your calculator and get a decimal equivalent, but you can't cancel anything out there. Now, J, K, and L, this is what you need to know before going on to the next lesson, our last lesson of the class. Here we are solving exponential functions with a base of e. And really, this is the same as what we did here at the beginning. So the first step is to isolate your exponential function or exponential term. This is my exponential term right here. So what do I need to do? I need to get rid of that 5, and that's 5 times my exponential. So I'm going to divide it over. So we get e to the 2x equals, and that's going to give me 25. So how do I get rid of an exponent with a base of e? Well, I want to match its base. And so we will multiply both sides by a log base e, which is just simply the natural log. So I'm going to take the natural log of both sides. So the natural log has a known base e. So natural log base e to the e, those cancel, that's 1. And I'm left with my exponent, which in this case is my 2x. And that equals the natural log of 25. So now just get x by itself. We'll divide by 2. Remember, natural log of 25 is a number, so I'm not doing anything with it. My final answer is natural log of 25 over 2. Okay, same concept here on K. I need to isolate my exponential term. That's my exponential term. So we got to divide both sides by 4. So we get e to the 0.5x equals 21. How do you get rid of an exponential with a base of e? Well, the opposite is the natural log. So those cancel, and I'm left with what the exponent was. 0.5x equals the natural log of 21. And then my last step is to get x by itself, and we'll do that by dividing. So we get x equals the natural log of 21 divided by 0.5. Now, while this is an answer, it's not fully simplified. I'm not sure if my math lab will take this or not. Dividing by 0.5 or dividing by a half is the same as multiplying by 2. So the best way to write this problem here is 2 natural log of 21. Okay, those are equivalent answers. I'm not sure if my math lab will take this. I know it will take this, and this is a better answer anyways. Okay, so the same, dividing by a half is the same as multiplying by 2. And then on L, you want to get the exponential term by itself. Well, it's already by itself. You have nothing being multiplied, added, subtracted, divided by it. So now to get rid of that e, we'll take the natural log of both sides. So those cancel. We are left with 10x minus 7 equals the natural log of 13. So now it's just a 2-step equation. We'll add our 7 over and then divide by 10. So x equals the natural log of 13 plus 7 divided by 10. Make sure you understand these last 3 problems before you move on to the next lesson, okay?